Hello everyone. For this video, I chose to start from my fascination for supporting for a football club. I started going to Ecoscaped when I was just 10 years old. It is one of my favorite things to do in the weekend, and I almost never miss a home game. I read in the newspapers that my club was looking for a new location to build a new stadium in the future. One of the locations was close to the city center of Genk. For me, it was a challenge to see if a new stadium could be beneficial for the water issues in the region, but also for the neighborhood. One of the biggest problems is the sewage system. When there is heavy rain, the sewage water flows over in the rivers. 1 in 8 houses is not even connected to the sewage system. If we want to reach the climate goals for clean water, Belgium needs to invest 3 to 10 billion euros in the following years. Because of the fragmentation of the urban fabric in Flanders, there are long pipes between the houses and the water treatment plant. This requires a lot of maintenance. The hardening routes all the rainwater to the waterways and the sewage system instead of giving it a chance to infiltrate, and this makes it harder for the water to clean. Right now, we have a linear system where we collect water and we store it. When we use it, we dump it in the sewage system that guides it to the river network and it ends up in the sea. For Limburg only, it is almost 170 million liters of water every day. I made a section of this principle to show what the current situation is. Right now, we drain the landscape. We use the water, we clean it, and then we dump it in the river and it's gone. When it rains, it flows to the sewage system, what makes it harder to clean, or it ends up directly in the river. Some people think that they are doing it better, just because they use rainwater for some functions like the toilet. But actually, they have the same impact in the system as flushing drinking water through the toilet, because the rainwater was meant to infiltrate in the soil, and now they move it to the sewage system. What I propose is a stadium that closes the water circle. The water gets purified by the gravity and then pumped up into the roof of the stadium. This roof functions as a water tower that can give the water back to the houses so they can use it instead of using rainwater. In this way, the rainwater can infiltrate in the soil. In this scheme, we can see the circular principle. I made it a zero waste scheme, so it has a smaller impact on the environment. For example, we could make natural fertilizer, installations from the plants, and even energy. In this way, nothing gets waste. The cleaning process exists of multiple phases. During the first 2 phases, a biogas comes free that we can use to make energy to pump the water to the tower. The plants are the last phase where the water gets its minerals. The plants also could be used to make insulation afterwards for the neighborhoods. As you can see, I work in a pixel that contains Genk in it. I started to analyze it to see where I could make a stadium. The important criteria were the distance from the city to the stadium, the mobility, and the space that is available. I did not want to erase a big part of the city just to fit a stadium in it. I ended up in the space between the railroads that is not used at this moment. It is located between the neighborhoods Winterslag 1, Winterslag 2 and Winterslag 4. There is a small hill between the railways, what makes it easier to fit my stadium in this location. The railways and the height lines determined the shape of the stadium. The stadium itself runs parallel to those 3 important lines in the landscape. The stadium will try to connect the neighborhoods instead of letting the railway be a separation and a hard border between the city and the neighborhood. In the master plan, we can see that the stadium is connected to both infiltration parks, the neighborhood and the Hasseltweg. The last one is important for the Spartacus project, where the tram stops. And this way, the neighborhoods will have a better connection with the mobility and other parts in the city. By making a circular system, the rainwater can infiltrate in the park. This park will contain recreational elements for the neighborhood, like a playground, sport fields, etc. The polluted water will flow through the roots of the plants and end up next to the stadium, for where it will be pumped up into the roof. In this section, we can see how the system would work. The water flows to the stadium by gravity, from where it will be transported to the roof. After that, the stadium will function as a water tower. The railways are integrated in the plan. There are bridges and tunnels so everyone can move safe. This image is an image of the infiltration park where a big wadi helps to let the water infiltrate into the ground. The park will transform an unused space into a space that can be used for everyone in the neighborhoods. In this way, the people and the planet part of the sustainability will come nicely together in this project. As I tried to make clear in the previous slides, a stadium could be used to connect instead of only to divide the neighborhoods. In this way, it can have a positive impact on multiple scales and themes like water, economics, recreation, work, housing, but also biodiversity. Just to give an example, there will be created a lot of jobs. People can learn about the system and how they can maintain it so that they can even try to expand it to different parts of the city, of the country. They also need people for the events, food, drink shops, greenery, etc. Last slide of my Pachacucha is a summary of the old situation and the new situation, where you can clearly see that the space did not get used in the start. Right now it becomes a park for the neighborhoods and it gets used by everyone that wants to use this space. Thanks for your attention.